In this video, we talk about section 10.1, Taylor Polynomials. We mainly cover linear approximations, quadratic approximations, and approximations using higher degree polynomials. We start with the linear approximation. Taylor polynomial of degree 1 approximation fx for x near 0 is given by this one. Fx can be approximated by this linear function f0 plus f prime 0 times x. This is also called the linear approximation. So now we look at an example. Find the linear approximation for fx is sin x near 0. So our function is fx is sin x. To find its linear approximation, we use this formula. So by this formula, we need to know f0 and f prime 0. Fx is sin x, f0 is sin 0, this is 0. F prime x is cosine x. F prime 0 is cosine 0, this is 1. So this p1x, by the formula p1x is f0 plus f prime 0 times x times x. So this is 0 plus 1 times x. This is equal to x. So we have the function sin x can be approximated by x for x near 0. So for example, p102, if x is 0.2, this number is near 0, right? We get p1 0.2 is 0.2. Sin 0.2, this is 0.1986. So from here we see that this linear approximation is close to sin function when x is near 0. So next we do the quadratic approximation. For the quadratic approximation, we have the following formula. Taylor polynomial of degree 2 approximation fx for x near 0 is fx can be approximated by this p2x. It's f0 plus f prime 0 x plus f prime 0 divided by 2 x squared. This is also called the quadratic approximation. So now we do an example. Find the quadratic approximation for fx is cosine x near x is 0. So for this example, our function f(x) is cosine x. To find the quadratic approximation, we use this formula. We need to know f0, f'0, and f'0. Fs is cosine x, so f0 is cosine 0. This is 1. Now first derivative is negative sine x. f'0 is negative sine 0. This is 0. f', this is negative cosine x. f'0 is negative cosine 0. This is negative 1. So after we know f0, f'0, and f', we can get p2x is f0 plus f'0 times x plus f' divided by 2x squared. This is our formula. Then we plug in the numbers. So this is 1 plus 0 times x minus 1 over 2x squared. So this is 1 minus x squared over 2. So now by the quadratic approximation, we know the function cosine x can be approximated by the quadratic function 1 minus x squared over 2 for x near 0. So for example, if we let x is 0.4, we can get cosine 0.4 is 0.921. Then this p2 0.4 is 0.920. So from here we see that this quadratic approximation is very close to the function when x is near 0. And if we do the linear approximation for cosine x, we get its linear approximation is the constant function 1. So p1 0.4, this is still 0.4. So this also tells us that the quadratic approximation is much better than the linear approximation for x near 0. So now, next, let's look at the approximation using higher degree polynomials. So if the function f is n times differentiable at the number x is a, then for x near a, we have the function f(x) can be approximated by the Taylor polynomial of degree n. So this is fa plus f'(a) times x minus a plus second derivative divided by 2 factorial s minus a squared, then plus fn's derivative a divided by n factorial s minus n a to power n. So Pnx is called the Taylor polynomial of degree n about x is a. So next we do an example. Find the Taylor polynomial of degree n Pnx for the function f(x) is e2x about x is 0. X is 0. So from our formula, we know that to find the Taylor polynomial of degree n, we need to know f0, first derivative at 0, second derivative, third derivative, and until nth derivative. But for this exponential function, fx is e to x, f0 is e to 0, this is 1. F prime x is itself, so the derivative is still e to 0 is 1. We know, in fact, for any I, the i's derivative of the function e to x is still itself. So i's derivative at 0 is still 1. So any order of the derivative of the exponential function is itself. So for x near 0, e to x can be approximated by this Taylor polynomial of degree n. So by the formula, this a is 0. So this is f0 plus f prime 0 x, then plus second derivative, then plus third derivative at 0, 3 factorial s cubed, then the nth derivative at 0, n factorial s to power n. So this is 1 plus x plus the derivative at 0 is 1. So 1 over 2 square x squared plus 1 over 3 factorial s cubed plus the last term is 1 over n factorial s to power n. This is the Taylor polynomial of degree n for the function fs is e to x, about x is 0.